Let us solve a beautiful question, which is actually very lovely question. And as per me, in gate they should not give. Only one time they have given. And along with the resistance part, not only with reactance part, resistance part they have given. When the resistance part is also given, how to solve the problem? Yes, it is lengthy problem. And mostly they can give for 4 marks maybe. They should not give for 2 marks as per my personal view. Okay. Anyway, many of the publications, they have given some formula. I don't know from where that formula came. Okay, some formula, and they got the answer. Okay, so we are sticking to the basics. We did not remember any formula. Okay, let us read. See, a 3-phase 50H generator supplies power of 3 megawatt at 17.32 kV to a balanced 3-phase inductive load through overhead line. The per phase total impedance is 0.25 plus J 3.925. So 0.25 is there. Resistance and reactance is 3.925 ohms per phase. Okay, and if the voltage at the generator terminals is given, the power factor of the load is. Okay, basically let us try to understand the question here. Here we know generator terminals. Okay, so inside internally this is generator terminal, right? And this is going to be transmission line, and this is going to be load. Okay, so at the generator terminals they have given 17.87 kV. Okay, so here 17.87 by root 3, and here this is going to be load side. Load side, the power of 3 megawatt at 17.32 kV, so it is going to be 17.32 divided by root 3. Okay, and here it is going to be the load is absorbing P. It is going to be 3 megawatt for 3 phase or 1 megawatt per phase, and this transmission line impedance is 0.25 plus J 3.925 ohm. Okay, here I have resistance, reactance. Now, means in our previous discussion of power angle equations or power angle characteristics, what did I say? Whenever you have resistance, actually without resistance, we are going to say EF Vt by X sin delta, or V1 V2 by V1 V2 divided by X sin of the angle between these two. Okay, but now resistance term came. So the moment resistance term came, I told you previously that don't remember any formula because probability of getting this question is very rare. Okay, let us derive. What's a big deal? Okay, so means I'm considering this as kind of EF, this as kind of VT. Okay, so we should not use EF VT by X sin delta because that formula is meant for when resistance is not considered. For example, this is going to be EF at an angle delta. This is ZS at an angle theta S. This is VT at an angle 0. Here this is IA. Okay, so how much is IA? IA equal to EF at an angle delta minus VT at an angle 0 divided by ZS at an angle theta S. Now what is power output here? Because here they have given power as 3 megawatt. So here how much is the power here? S output. S output is going to be VT IA complex conjugate. Okay, so what is S output? Is going to be VT IA complex conjugate. So VT into IA complex conjugate, in the sense EF by ZS at an angle theta S minus delta minus VT square VT IA complex conjugate divided by ZS at an angle theta S. So what is P output? Is going to be EF VT by ZS cos theta S minus VT square by ZS cos theta S minus delta here, cos theta S minus delta, and this one minus. Okay, so in this you have to calculate what is EF, what is VT. You are going to get delta. That's it. Okay, so for example, how much is EF here? How much is EF? Sending it. How much is this? 17.87 by root 3. So 17.87 by root 3. Okay, so 17.87 by root 3, which will come down to, we will see. And what is VT? VT is going to be this side. Okay, 17.32 by root 3. 17.32 by root 3, which will come down to 10 kV. Okay, and EF is going to be 10.3175. 10.3175 kV. Okay, now what is power P per phase? Is going to be 1 megawatt, because for 3 phase they have given 3 megawatt. Okay, so let us include that here. This is going to be 1 into 10 to the power of 6 equal to EF 10.3175 into 10 divided by, how much is ZS here? ZS is going to be 0.25 plus J 3.925. Okay, is going to be having the magnitude of, just a minute, 3.933 at an angle 86.3. Okay, now you please place all those things here. How much is ZS here? 3.933 cos theta is 86.3 minus delta, I don't know, minus Vt square 10 square divided by ZS 3.933 cos 86.3 degrees. 10 to the power of 6 can be removed, because kV, mega only, mega I removed. Okay, it is going to be 1. Now from here, can we calculate delta or not? Everything is known except delta. Now calculate the delta. Delta will come down to 2.07 degrees or 2.1 degrees. Okay, now you know delta. See here, you know here EF at an angle delta or V1 at an angle delta. You know V2 here. Okay, so can you calculate IA here? Yes. So how much is IA? EF at an angle delta minus Vt at an angle 0 divided by Zs at an angle theta s. So try to calculate IA. Is going to be, EF is going to be how much? 10.3175 at an angle 2.1 degree minus, because delta is 2.1 degree. Okay, minus Vt is 10 at an angle 0 divided by, okay, Zs. How much is Zs value? 3.933 at an angle 86.3 into 10 cube amperes. Okay, so calculate magnitude of this and the power factor angle. So with respect to Vt, you know Ia angle you are going to calculate. That is going to be the load power factor, because what is the question they asked? See here, the power factor of the load is. Okay, so if I consider Vt at an angle 0, Ia at an angle minus of something, we can get it from here. Okay, so if I calculate Ia, it will come down to 124.4 at an angle minus 35.7 degrees. So what is power factor? Power factor equal to cos 35.7 is going to be 0.812 degrees. Sorry, 812 lakh. Okay, yes, this is lengthy question. Now actually, like, you know, as I said previously also, I don't know from where they captured that formula. It is not required, because even if you try to remember formula now in exam, you will not be able to recollect it. So stick to the basics. Is it difficult to derive this? No, right? So EF at an angle delta minus Vt divided by Zs at an angle cos theta s, Zs at an angle theta s is going to give you current. That's it. Okay, so from that current, S output is going to Vt Ia complex conjugate. Over. So did we remember anything? No, except this. Do we need to remember this? No, not required. Easily we can solve problems.